anyone explain to me why can this cam balance on the side, and why did that thing, that seemingly impossible thing, balance at the tip of the toothpick? Did you observe? Did you observe? Meaning that the toothpick supported by equal force. Okay, it was balanced at the tip of the toothpick. Then the other one, if you achieve the cam was like that. Can you explain why? Everybody says center of gravity. Good. What do you mean by center of gravity? Because we are engineers, right? I mean, if you are from business school, you just tell me CG law, then people say, what do you mean by CG? Then most of the time, business student will start there. Then most of you say, I go further. So you guys are engineers. So you must, at least have some answers for whoever going to ask you. So CG, then the person, what do you mean by CG? Reaction for something along that line, right? Okay, good. So you guys, okay, don't worry. So if anybody asks you next time, if you do this during your dinner or whatever, these are some common dinner tricks that you can perform to impress someone. You can. This is what you're going to tell them. By the law of equilibrium. So what is the law of equilibrium? That's what you're going to learn. And it's a very simple law. By the law of equilibrium, this is the reason why that body is what do you call that? In that position. So what you're going to see, what you were supposed to see was like that. The law of equilibrium, this is what you're going to learn. The law of equilibrium says that what? There's only three equations. Summation fx, and these equations are very familiar to you. Sum up all the forces in the x direction must be 0. Sum up all the forces in the y direction must be 0. Sum up all the moments about any point must be 0. This is all you're going to learn tonight. Yeah? It's as simple as that. Law of equilibrium, next time people ask you, what is the law of equilibrium? The law of equilibrium is a physics law, right? It says that for a body in equilibrium, that means, what do we mean by a body in equilibrium? This is in equilibrium. You sitting on the chair is in equilibrium. This thing down there, so-called not accelerating or not dropping down, is in equilibrium. Yeah? So if a body is in equilibrium, these three equations hold. It's a universal law. No one can defy this law. So, meaning that, based on this law, summation fx must be 0. So that will imply that there are no x forces. Yeah? Summation of forces in the y direction must be 0. It just implies that, well, CG, as what you mentioned, and reaction force. That's what we learned, free body diagram. Okay, now let's go back to the free body diagram. You have to draw the free body diagram of the body, assuming that someone drank the water and so the CG and this thing. So free body diagram, what do we learn? External force first, right? Any external force on the cam? No, no external force. Second, what is the mg? The internal force, which is mg, which is CG just now was mentioned. Last one is what? Reaction force. That means every body must be supported by something, right? It is supported by at a point there. So can you move in the x? Free to move, assume that it's frictionless. Can you move in the y? Cannot, right? So ry. Put ry so that you can relate. Yeah? So the law, first law says that summation fx equals to 0. Of course, there's no lateral forces. Second law, second equation based on the law of equilibrium. The summation of forces in the y direction must be 0. It means that ry must be equals to mg. Do you understand? Yes. Okay, good. Last one. Last one says that take moment about any point must be 0. What does that imply? That implies that the CG must be here. Clear? So that it is along this line. Okay? Okay? Very logical, very scientific, right? This is how you want to explain to them. Clear? Because the law of equilibrium, it applies to every single thing on this earth. Every single thing which is in equilibrium. equilibrium. Summation fx must be 0, summation fy must be 0, summation moment about any point must be 0. For this case, in order to have summation moment must be 0, they must act along the same line. Any offset will create a resultant moment. So this is the answer. Same goes for the what do you call this? The fork. And supported by the toothpick. Exactly the same. Or it's a quick sketch. No. It's a quick sketch of the fork just now. Right? Being supported just now, our toothpick was being poked through, right? And supported by the other toothpick that was in the I think it's salt or pepper. Yeah? So same thing, same logic. You know that the reaction force is acting here and it is in line. That's why it is balanced. Okay? Okay, that's just for starters. So next time we talk about equilibrium. Or you can actually recall these things that you have witnessed, then you can have a better understanding. So, whatever I said just now, was, I said quite very right. It is all in this paragraph here. So it is so short. Equilibrium, what is equilibrium? Equilibrium condition is summation fx, summation fy, summation moment must be 0. And that is all that you need to know. At least know only, not you haven't applied yet. And yeah? Okay, so just now I gave you an example, right? Remember this particular example, where was it? This one. What did I say? I said that applied and standard forces are known forces. These are the two unknown forces. How are we going to find these two? Very simple. If this body is in equilibrium, then since the body is in equilibrium, what must happen? Summation fx must be 0, summation fy must be 0, summation moment about any point must be 0. So if you are drawing a reference frame x, y, and a with a moment, when you sum out all the forces in the x direction, you will have this, right? And these two components. Agree? It is just like the resolving of forces again. You sum them up. That means Rx is pointing in my negative direction, so negative Rx. So let's say this is 40 degrees, let's say. So plus 100 cosine 40 must be 0. That's what the law says. Summation f1 is summation fx. Now summation fy, what do we have? We have minus 100 plus ry. Any more? Yes, some more. Minus 10 sine 40 must be 0. Yeah? Two equations, two unknowns. Can you solve? You can solve. Using what? Simultaneous equation. That's what you learned in the very first lesson. Yeah? So this is what chapter 2 is all about. From the very start, we told you that you have to be proficient in simultaneous equation, trigo, and Pythagoras theorem. Now everything is back. Okay? So this is the overall picture. You learn about forces, you learn about moment, you learn about free body diagram. Tonight, you learn about equilibrium. What is equilibrium? Anything that is not accelerating. A equals to 0 means it's equilibrium. When the body is in equilibrium, you have these three equations. These are the three law equations that the law of equilibrium states. By having this equation, you can establish equation to solve the unknowns. So you get a big picture, and this is what chapter 2 is all about. Clear? Oh, don't worry. In your example, we'll show.